Welcome everyone to the Highly Automated CAM webinar on NX CAM. Thank you for taking time out of your day to join us. I am very excited to have Brian from Siemens Digital Industry Software. He's a CAM expert and he will be presenting today. I would like to ask that you all click on the More button on the top of your menu bar and select full screen and focus on content in order to better view the presentation. You will be able to type all of your questions in the chat, and we will answer those questions at the end. So enjoy the presentation. Take it away, Brian.
All right, Kim. Hey, thank you all. So, hey, thanks for joining us this afternoon. Again, this is Brian Dreibelbis with I'm with Siemens, actually channel enablement support. So I support the partners throughout all their CAM activities in the Americas. All right, so with that, let's talk a little bit about automation to go with that. So one of the things that we see with automation is really the challenges that are going on, amongst all manufacturers, or really lots of businesses in general, is there's lots of competition, right? And lead times get compressed to meet that competitive nature of the business, right? And everything becomes in just-in-time type manufacturing going on for many years. And then the increased complexity of parts also is becoming a challenge with that. So smaller parts, more complex natures to the geometry and surface type geometry that goes on, making even complex tooling. And then quality standards obviously are being raised across everything. So you want to meet that, and that all rolls into that competition. And then, of course, lastly, we've been all suffering with this disruption in the supply chain, right? So all these things are we see as industry challenges that are driving people towards automation. And amongst that need for automation, I guess you would say, is these are maybe three. There's many more, but these are the top three of the objectives everyone's looking to do. Is they want to increase the throughput, right? Everybody wants to get parts out the door faster, right? You want to have shorter machining cycles. You want to be able to set up machines faster, right? And you want to minimize all your downtime, right? And get paid for that. And then, of course, that whole thing about improving quality, that helps you win more business to go through. Everybody wants quality products at a great price. And then the ability to give some of that time back and help you expand your business into other areas. Some move into new generation of products. Some start adopting more, we say, innovative technologies. Robotics are really coming on very strong everywhere, not only in the automotive nature, but even down into the smaller tool shops. We keep running across more and more people adding robots into the work cell environment. And then again, there's new business models that are coming around. And all these things can be helped and met by automation to systems involved in manufacturing, specifically more NX CAM. So it really is automation. It's really a must thing that lots of people do to remain competitive. Without it, right? You know what the time it takes, but if you can take time out of your cycle, 10%, 20, 30, 40, 50% out of all of that, quote, non-value add, the programming time on parts, this can be huge and overall in times of the year that goes with that. So while we dive a little bit deeper here, is we're really talking about program automation with feature base. There's quite a few other methods of automation involved inside of NX. Beyond toolpath automation, there's many other capabilities we have to automate things, just like the templates or repeatable process, automation of setup of machines, automation of assemblies. If it's a repeatable job, be able to just drop that job into a template, right? And all you have to do is select the new geometry, and all your methods, your tooling, everything comes into place. All those can come into play with that on feature base. So today we're going to focus specifically on feature base, and really the goals of that would be is to capture and reuse proven processes that you go on. So it's not that you just get feature based that says this is the way you cut the parts, the way we said, Siemens says we created that, but you can actually create your own tool paths with your own speeds, feeds, tooling, methodology, however you like to approach the part, and then those get reused as we find those features on those parts, which become then your practices and your proven processes, right? And we see across many industries with that we see the increase of efficiency and the amount of programming time of saving up to 90% of the time it takes to program a part, you could say by hand, even inside of a CAM system, by just using automation and feature-based. Okay, so the key thing again about NX, for those of you who don't know much about NX, NX is really a one system solution, everything from design, simulation, manufacturing, to all the way out to the shop floor. It's all inside of one system. It's not a series of different solutions. It's all integrated in one. So if there's an update or a change, or you want to be collaborative with someone, it's all one solution. It's one data set. And really that covers the wide range of capabilities inside of just CAM from a toolpath perspective, right? There's obviously 2.5, 3, 4, 5 axis. We have specific applications for just turbo machinery. So parts involved with turbine and turbine machining like that is all very automated. You can almost open the part and just recognize what's a valley, what's a blade, what's a splitter automatically, and it roughs finishes and provides all the toolpath there literally in a matter of a few minutes. Through mill turn capabilities in NX, and the way we approach mill turn is you obviously would have a turning capability, so we would have NX turning, and to that you add the appropriate amount of milling you need. So if it's just a live tool mill turn, you just add 2.5 axis milling to it. If it's that with Y axis, maybe 3 axis. Of course, then if you go into 5 axis, you have a 5 axis head, we would add 5 axis to that, so we can get the right price and the right solution, so you're not buying this large bundle of capabilities that you maybe have no need for. NX also has wire EDM, 2 and 4 axis wire EDM. Again, all these things are hooked up in the feature base: 2.5 axis milling, turning, mill turn, wire EDM. Of course, part of feature base is hole making, and then the ability to define features, your own features and your own processes to go back inside of feature base, and which all works in couple with the tooling libraries, right? So if we know we find a feature, we know we have to have the tools necessary to machine that feature. And if not, we can make substitutions for them if they're in the tool library. And then that communication out to your shop floor documentation, which can be work instructions to go on with that, your tooling list, cycle times, etc. Like that is all be output in NX through shop docs. On machine probing, of course, that's all inclusive of the same thing inside of NX. And then obviously you need post-processing. And then we have our machine tool simulation, which is a G-code driven machine tool simulation that's available to add on to any of the particular machining capabilities. So with that, we say is how does that all work, right, from a higher level? Then we're going to jump into some feature base here. Let's just say we really look at this at a digitalization from part manufacturing, where we have applications for the model preparation of the part, right, to go in, because sometimes you get the part, but the way that you get the finished part necessarily isn't the way that you're going to approach it and machine it. So you have to know where the stock is. If it's a multi-setup part, you know, you got to turn it around, you got to move it in through different fixturing like that. All of those things are used inside of NX. We call it our in-process work piece. So as the part gets machined, we always know exactly what the remaining stock is. So if you take that and move it to the next fixture or flip it over, whatever the case may be, transfer from subdomain spindles, you know exactly the amount of material that's remaining and the amount of material where you would be clamping on if you're letting some there that would be cleaned up yet in tertiary operations. And then obviously into the toolpath capabilities, and then all the way to shop floor connectivity. We can do the validation out on the shop floor, and then obviously run that. And that all has related applications to that, right? Which would be that whole data on the bottom there. If you needed CMM programming, and XCMM is there. So again, the same part that's there. We can read PMI. If PMI or model-based definition is put on there, we automatically will program the CMM for you based on those features. When it finds those features or anything that's tagged with a dimension and or tolerancing, will get automatically added a CMM, a probing path, right? And then you can move into things like process planning. You can go more into elaborate, more tool libraries or tool management with that. And then we also have a CMM execution product, which actually we end up driving the CMM directly, you could say, from outside of NX. So that's all part of that capabilities that you could say ties together inside of automation through having that digital workflow, if you would, through part manufacturing. So with that is, we talk about this connectivity, right? It's a single source of data. Obviously, this can be imported data if you want. We read almost all CAD formats. So you can bring that into the manufacturing environment. And from then on, everything else is associative to it, the tooling, the fixturing, the process, et cetera. And again, you can capture and reuse your expertise that goes back in. So we can do that as things from everywhere from tool selection all the way to the way you machine given features, or maybe you want to do this, as we call it, a templated approach. So if this is a kind of part or a style of machining you always do because it's the same similar kind of part, you can have that as a template. Some people use templates that represent a given machine and the standard tooling on it. So they get the machine out, put it on the desktop, drop the part on there and the fixturing with that. And then again, if it's automatically has facing, roughing, pocketing routines, you can just drop and drag those onto those individual features. Again, the whole idea is to speed programming up from picking and clicking across parts and surfaces and multi-holes, et cetera, like that, to have the intelligence inside of NX do that for you. And of course, you can always do this by a cloud-based collaboration. Everybody and everything's moving more and more to the cloud. You can run the software cloud across the cloud if you would, if you have multi-sites like that. You can do it by collaboration. So if you have multiple facilities like that, so you can share data, view data between two, send data back and forth to each other, all through the cloud connected apps. All right, so next, I guess what we're going to do is we're going to take a look at NX CAM and automation. Really, we're going to start a little bit of a deeper dive into feature-based machining. And what I have too is I have 3 other people had done some presentations for us and helped us do this. This comes out of our product development side that comes back over. So I thought Lars Okel is going to show us really how all this can be achieved inside of NX CAM with feature-based. And from Lars' experience, he's worked well over a decade in some of the largest mold and tooling shops in the world using feature-based. So over to Lars.
My name is Lars Okel. I'm from Denmark, where I live with my family. I work for Siemens Digital Industry Software in the manufacturing engineering group called Solution Incubation and Management. My main focus is NX CAM for manufacturing, specifically parts manufacturing, injection mold manufacturing, and programming automation. I've been with Siemens for nearly 12 years. When I joined, I was living in China, where I was working for one of the world's largest consumer product manufacturers in one of their injection mold manufacturing facilities. Today I'm going to talk to you about programming automation in NX CAM using feature-based machining and how you can get started with that easily, and how that can be of value to you in regards of product quality, consistency, manufacturing cost reduction, better resource utilization, and all of that helping you to stay more competitive in today's market. Respondents to a recent study identified the time to delivery as the single most important driver of change for machine shops. Machine shops have common operation goals. They try to save time in programming and accelerate machining processes. They also try to maximize resource utilization with automation, lights off machining, free up capacity, while reducing costs and achieving the required quality. In this presentation, I'm going to address mainly the first point, which is reduced programming time. But today's topic will also impact the other points. Automation in CAM programming provides a major opportunity for competitive business advantages. To automate the NC programming process, you can use feature-based machining in NX CAM. It can automatically recognize machining features and create complete machining processes. Feature-based machining is ideal for programming parts with many features, such as pockets, slots, and complex holes. Let's say you've got an engine casing or mold plate with lots of holes on it. To pick the holes manually and program them is tedious, and it takes a long time. With feature-based machining, you can cut the programming time down dramatically. It gives you the ability to not only go faster, but to get consistent results because you reuse the same proven processes time and time again. You can also teach the system to recognize special features and to assign your special machining methods to those. So when you need to program a similar job, NX will apply the preferred machining methods automatically. How does it work? The first step is to recognize features in your part model. This is done using feature recognition, which can recognize more than 70 different features out of the box. Then based on machining rules from a knowledge library, the features will automatically get optimized operations assigned to them, which machines the features according to their specifications, of course using the correct cutting tools. This all fully automatic. The knowledge library can be modified so features are machined exactly like your company-proven know-how dictates. Then you must generate the provided operation and do a sequence optimization to make sure the machining process is as efficient as possible. Finally, you post-process to get the needed NC output for your machine tool. NXCAM can also look at the CAD model and read product and manufacturing information, also known as PMI, that has been attached to the solid model by the designer as 3D model annotations. NX can detect PMI like dimensional tolerances and surface finish as data that could affect the selection of the machine process and tools. For example, a different level of tolerance could mean that we need to select a different machining method, perhaps with extra operations. Now let's see an example of programming automation using feature-based machining and how that can lead to greatly reduced programming times. It can take a lot of time to program parts with many features, like this mold plate. As mentioned earlier, NXCAM can automatically recognize all the features on the part and create optimized machining processes using the right cutting tools, eliminating manual input. In this example, within minutes, 85 operations have been created to machine 111 machining features using company-proven knowledge and guidelines. To recap what you have seen so far, feature-based machining provides extra value in programming automation. In addition, capturing and reusing your knowledge is a powerful way to increase efficiency. Programming time saving by as much as 90% have been reported from customers. You may ask, how do I easiest get started with feature-based machining? Well, we have created the documentation and content kit helping you with exactly that. We call that the FBM Starter Kit. The Starter Kit gives users an easy-to-follow way to begin using feature-based machining with a collection of examples that takes users through various scenarios. It is not an out-of-the-box solution for users. This is simply due to each company using specific cutting tools, materials, machining techniques, and so on, which is not possible to predict and deliver with the kit. However, the kit does come with predefined machining processes, which allows easy modification directly in NXCAM. The kit also comes with a predefined standard tool library, including feeds and speeds. The only prerequisite is NXCAM knowledge, especially how to create milling and drilling operations, as well as an understanding of the tool library and use of it. The kit contains 4 different example parts. A housing part with 30 features. In that example, we demonstrate how FBM can automatically create multi-sided machining processes. You will also see how you can update machining rules. Then we have a stamping die plate with 117 features. That example demonstrates how FBM in combination with surface color usage can optimize plate programming. And then there's 2 ejector plate examples, one with 63 features and another with 38 features. Those 2 examples shows you how easily you can program these types of plates with NXCAM. You can get the FBM Starter Kit directly from the Siemens Support Center. You can also contact your local sales rep for more information. Now I will show you a couple of examples on how to use feature-based machining with NXCAM on a couple of ejector plates. First, we find the features, and it's only necessary to look for the features that we know are there. Right? So you don't need to search for YDM features when you know those are not there. When the features are found, we simply select them all and create feature process. That's all the operations that we have made rules for. And I'm using a real time here. There's no trick with what you see. It takes this time. and then it just runs through all the features and determines which operations to use. So that's done, and you can see here that we have different operations for different features found. Now, the next step we want to do is to make sure that our cutter tool sequence or cutter tool usage is optimal. So we go and optimize and minimize tool changes, and then we can simply just generate. And again, here I'm not cheating. We're just using real time, and then it's generating operations from the back and from the front. And for those of you who are familiar with programming ejector plates, you know that this is, although it's a simple plate, but it is time consuming because of the amount of features. And yeah, but with feature bases, you can see here it's done very, very quickly. Now the operations are generated, and we can do a simple verification using our simple play. Or if you have a machine tool setup, you can use machine code simulation. In this case, I'm just using simple play, and it runs through quite fast, just to checking that nothing is missed. Then we are nearly done, and ready to send this to post it with our post processor and send it to the shop floor. And that's within a couple of minutes, as you can see. A second plate. Again, we find the features. Features are found. We create the feature process, the operations. Once that's done, then we will do an optimization, again like we did in the first one. You can see here that it's real time again, just to give you an idea of how fast this really is. And then you have operations from the front and the back and ready to be put on the machine tool. Now let me share one of the customer success stories we have from an Asian customer that is using feature-based machining and automation with great success. The company is ASM Pacific Technology. It's one of the world's largest suppliers of semiconductors and electronics equipment. They have global operations with 10 R&D centers and 12 production plants in Asia and in Europe, including factories in Shenzhen, in China, in Singapore, and in Malaysia. The discontinued software systems and geographical separations between its R&D centers and manufacturing plants created significant gaps between ASM's design, development, and production activities. Since the 3D data of the machinery components transferred to the factories lacked complete product information, the production didn't capture design intent. This made it difficult for data to flow seamlessly between design and manufacturing. This disconnected process affected their overall productivity, which was most evident when the design changes were requested. It required significant time to transfer design changes from the product development centers to manufacturing. ASM then realized it needed to integrate product development and manufacturing. In order to realize a seamless process between design and production, ASM deployed NX. The most immediate benefit of applying NX CAM is the automation enabled by feature-based machining. Automatic recognition of machining features is driven by the product and manufacturing information, PMI, such as tolerances and service machining precision attached to 3D models by product development. Depending on the recognized features and associated PMI data, NX CAM automatically creates the best machining methods, processes, and tools to manufacture the entire part that can have many machining features. Manual programming of these complex parts can be time-consuming and prone to errors. With NX's feature-based machining, ASM reduced NC programming time of complex parts by up to 91%. Additionally, feature-based machining enabled ASM to create standardized machining operations, improving the repeatability of manufacturing processes. This enabled a seamless link, the digital thread, between design and production operations, effectively transferring the original design intent to production. Part quality is another focus for ASM. NXCAM integrated simulation helped ASM to reduce errors and improve part quality. Instead of conducting tests on physical machine tools, ASM engineers used a digital twin of their machining processes to validate the NC programs for accuracy and reliability. This ensuring the first-time success of machining operations, which improved part quality and minimizes scrap. This combination of high level of programming automation, end-to-end connectivity, and virtual validation of machining processes enabled ASM to improve overall production efficiency by 70%. To learn more about the comprehensive NX for Manufacturing portfolio, you can visit our website. Our blog helps you stay informed about the latest news and success stories. Our public online manufacturing community lets you join the ongoing discussion between your peers and experts from all over the world. To discover the power of tomorrow's CNC programming, you can try NXCAM in the cloud. Just search for NXCAM trial in your web browser, register, and start using NXCAM in your browser within minutes. Thank you for watching my presentation. I hope it piqued your interest in NXCAM and programming automation.
All right, well, thank you, Lars. Lars had put that together for us. Obviously, we have a little bit of a time difference between Denmark and the US. So next, what I have is really we can take a deeper dive using feature-based and the capabilities. And so again, I have two other experts from development here that'll show us things of how you can create the teach mode inside of feature-based, where you can teach it to cut any kind of feature with the processes you want. And then we'll have another short segment in there about how feature-based actually works using PMI and tolerance information to help drive and raise that product quality. Next, I'd like to introduce Joe Taylor and Steph Brussel. They'll be showing us some more detailed features on how NXCAM is used in the teach mode to teach and recognize features and the value and how to use PMI.
So, good afternoon all, and thank you, Pedro. So let me start by showing first the result of the automation I did on this that's so-called test part. And you see I have a mold here with different sliders, so different dimensions of the slider, so the width and the depth. So it's a slider open pockets and closed pockets with some holes in there. So you see M5 holes, M6 holes. No operations defined yet, no tools defined yet. The only thing I defined before is my workpiece, so my parts to be cut and my blank material. So that's the only thing which I defined. And the first step I'm going to do to make this clear is that I'm going to search for geometry which NX recognize. So in this case, pocket slider, that's created as a custom feature to recognize, and I'm going to check steps here, and that are just the holes, blind or through holes, with thread, no threads. That's all the same. The holes recognized, that's out of the box stuff. The sliders which I'm selecting now, that's the custom stuff. Next step will be select it all, and I can create a feature process for this. And so not only the holes, which are best practice out of the box, but also in my operation set, there is a custom operations created based on the geometry which is recognized. Now you can see if I go back to the operation navigator, so to the operation navigator and to the geometry view, you see that there are 3 groups created, 3 feature groups, and some operations and some operation groups. with some operations in there which I can generate directly. And this is a three-step done in 3 steps, let's say. So after generation of these operations, I already have my toolpath available. So as you can see, it's coming up now. This will take, in my case, with the slider and all the holes, like spot drill, drill and tap, it will take 30 seconds. And so it's a roughing operation in there, it's a finishing operation in there, and it's a spot drill for the M5 holes and a spot drill for the M6 holes, and drilling and tapping also. If you want to do a treadmill on different size holes, it's also possible. I just defined this as a tapping thread. So this is how you get to the end result. Let me now show you that, well, of course, this will be the normal operations, but now I'm going to show you how to get there, how to get that automation. Now I'm going to show you here, this is my teach part. It's in a different mode with some predefined operations in here. Also normal operations just created by NXCam. Next step will be that I'm going to teach NXCam to recognize this slider geometry. Yeah, so we have the 3 levels, 2 open pockets and 1 closed pocket. I'm going to tell NX that he, from now on, will recognize the geometry forms like this, even when the dimensions are different. I'm going to create a new feature type and give it a logical name. So pocket slider, I'm going to call this one. I need to define a recognition rule. I will use the same here. So let me use the same here. It's going to give an enter. The pocket slider is done. And then the only thing what I have to do, and this is a one-time effort, I only have to select the geometry. So when I'm selecting all open and closed pockets here for this slider pocket, it will be stored in the database and ready for reuse, which I'm showing you in a second when I teach this recognition rule. So I'm going to hit the teach recognition rule, hit OK, and then it's stored in the database. Now, just for testing, I'm going to do find features again, as I did before on the other mold. And as you can see, when I check the pocket slider, recognize or find feature, and this will be a pocket slider 1. The number 1 means that this is the first feature of this kind. If you have 15, that probably will be 15 numbers. And so next step, I'm going to create a group from that. And now I'm going to create a group that is not really logical with 1 feature, but if you have multiple, there will be multiple features in this geometry group. Give it a logical name again, and that's what you have to do with automation anyway. Make logical names and use logical names just to let you know what you're doing and what you're dealing with. Drag the operations in there. And then the second step in this automation, I'm going to teach NX to apply these 2 operations when this feature is found. So in the teach operation dialog, I can show you that all attributes available in the 2 different operations will be there. So that's the feature operation parameters and the tool parameters. So that this is all available for further customization. Joe will show you later in this session a bit of that. And of course, some other attributes which are available for customization. Teach the machining rules and hit OK, and then the second part is also stored in the database. So the feature recognition is stored, the operations are stored, and that's basically what it is to automate this. Now let me show you the same mold. I'm going to just change the color here, so you can see that it is a new test of this part. just gonna do this stuff again. I'm gonna show you that it's the same part, but then with the part defined, blank defined. Gonna find the features here. Select the pocket slider, select the steps. As I said, the steps, that's the out-of-the-box best practices content, which is already there for everybody who has NX installed. Select all, found features, create a feature process, and then that's basically the 3 steps what you have to do. Find features, create your feature process, or create your geometry groups with the operations, and the last step in this will be just generate them. And that's also something all tools retrieve from the library. That's done automatically based on the rules you define. Then just generate all operations, and that's it's going to take 30 seconds, and I think it's 35 seconds, and then all the operations are done. And from now on, all slider pockets I'm going to create in future for any of the molds with the same geometry will be recognized. So roughing is done, finishing is done, and the spot drill of the M5, spot drill M6, drilling for M5, M6, and tapping for M5 and 6. And that's it, basically. That's all there is. So over to you, Joe. Thanks for the time you invest in this. And Joe is going to show you a bit more on the automation, including PMI. So thanks.
Sorry guys, I was on mute there. So I hope you can all hear me. Good afternoon. As Pedro has already introduced me, my name's Joe Taylor and I work for the UK team as part of the pre-sales for NX Cam and NX Additive. And I'm going to follow on from what Steph's just done a really nice job of introducing around feature-based machining, but with a focus on PMI, product manufacturer information, and how that is a driver and an influencer in the operations and tools that are selected when it comes to automatically creating operations against features. So first of all, I'd like to just quickly open up a sample part. This part, I'll share the link to all of the attendees later on. You can get hold of this as part of the feature-based machining kit. It comes with everything you need to get started. But as you can see, pretty generic style part. We've got some PMI on the components, some for surface finish. We've got a H7 limit fit, some linear tolerances, and we're going to be talking a little bit more about this pocket a bit later on, this 40mm wide pocket with a plus 0.6 less nothing tolerance. Well, first of all, I want to show you a little bit about how we use PMI on products in NX Cam. So I'm going to create a new manufacturer setup, so that's entering the CAM part of the application for those not familiar with NX. And what I'm then going to do is create a clone of the design data, which we call a wavelength body in NX. And when we do that, we create an associative link, which allows us to work on a body which isn't the design part. So we've got freedom to work with the data. And as you can see, it also brings through the PMI. So we've now got an associative link to the design part for geometry and PMI. The next part of the workflow is to create the workpiece, which is basically specifying what we want to machine. So I can select the geometry in the window. And then we can do the same as what Steph did and start the feature-based machining steps, which is basically to, first of all, find the features. And for this first example, I'm just going to look at the holes, which we call steps in the feature library. And in particular, I'm only interested in two holes, sorry. One hole that doesn't have PMI directly associated with the size of the hole, and the other one which does. Okay. So when we go to our nice selection tool in NX, I can select the feature in the UI, and you can see that in our feature navigator, it displays the features for us. We switch on the PMI toggle, we can see that there's a linear dimension against both, but this one also has a H7, a limit of fit tolerance. So that's a tolerance on the diameter of the hole. So if I create the feature process, first of all, for the hole that doesn't have the PMI, NX is going to look at the hole, it's going to look at the size of the hole, it's going to select a tool and appropriate operations to machine that hole. It's a 10 mil hole, so it's going to spot drill, which does two purposes, spots and creates a chamfer. The second operation is to drill the hole size. So it's selected a 10 mil drill and it's gone straight in with a drill operation. Now let's have a look and see what happens when we apply the same rules to a hole that has a limit of fit tolerance. So again, we go through exactly the same steps. We don't have to select anything differently. We simply run the feature process operation. And this time you can see we have an extra operation that's been created. So the PMI and the tolerance has driven NX to output, again, a spot drill to drill a chamfer, again, a drilling operation, but this time it's selected a slightly smaller drill. And that's to leave some stock material into either ream or in this case, to bore the hole to size. So it's all about using PMI to drive the decisions that NX makes around which operation types it's going to use. So it's all very well on holes, but what about other features on parts? Very similar to what Steph just showed us with his slider. Let's have a look at this pocket. So the first thing I'm going to need to do to decide how we're going to machine it is to find the feature. So the same way that we went about it for the holes and the same way that Steph showed is simply searching for that feature type. In this case, it's a slot. I can disregard the other feature. I'm only interested in the one. And then the same as what Steph did, what we're going to do is create a feature group on this feature. The feature group allows us to then create the specific operations that we want to attribute to the feature, and as Steph did before, teach those back. So again, I'll just rename this something logical. I'm going to call this PMI slot because it's PMI on the slot, and that's the example. And I'm going to put R and F because I want to rough and finish this operation. If I was looking at this from a machinist point of view, plus 0.6 less nothing is quite a big tolerance. So I'm going to create a pocketing operation and I'm going to finish that pocket in a single operation. So I don't want to leave any wall stock in. Just going to pick a tool out of the library. We've got quite an extensive out-of-the-box library, so I can just search for a 12 mil tool, pick the first one off the top of the list just for this example. I can then go through the dialog, change some parameters. I'll make it a follow parts, which cut in an open pocket, select the thickness, and I'm going to turn off cut compensation because, as I said, plus 0.6 minus nothing is an open tolerance. I'm very confident my machine can hit that limit very easily. So you can see in a couple of seconds, we've created the operation, I've simulated it and validated it in the display, and that's great. Now, what if that tolerance was a tighter tolerance? What if it was, plus or minus 0.5? So this time I'm going to copy that feature group, rename it to rough and finish with CutCom. Okay, I'm going to have to just reassociate the feature group with the feature. And then what I'm going to do is look at that first roughing operation. And this time I'm going to leave some stock because I want to break it into two operations. If I was machining this, I would want to run the finish path a couple of times to ensure that we get into size. So what I'll do is change the parameters in the roughing operation to leave 0.5 mil material on the walls. And then what I'm going to do again, a nice feature in NX is to copy and paste that operation, rename it as F for finishing. And I'm going to change some more parameters in this operation. So I'm going to return the stock to 0. I want to finish the wall. I'll select a profile cut pattern because I only want to cut once. And I'll turn on the cut compensation because I want that extra level of control from the machine's point of view. And there we have it. I've now got one feature group for the feature to finish in one go, and I've got another feature group to finish the operation in a rough and a finished operation. Now what we have to do is very similar to what Steph just showed us, and that's to teach the operations. But this time I'm going to add some intelligence. I'm going to apply some logic. So again, using all the attributes that are available to us, I'm going to select the upper and lower length values. So in this case, it's a plus nothing plus 0.6, but it could be a plus or minus. So for that reason, I'm going to do the lower value times -1. So if it is a minus 0.2, that will make that a positive number. I'm then going to add that to the upper limit. So if it was -0.2 plus 0.2, that will give us a tolerance band of 0.4. And then I'm going to add a condition. So I'm going to say, if that value is greater than, say, 0.2 millimeters, I want to use this operation and this operation set that we've just created. So once I've taught that, I'll just copy this string to save time. Once I've taught that, that's now in the database. That's now in that feature library. So I can now go into my second feature group. Again, go into the teach operation sets. Again, you can see all the parameters for both operations and tools are all available. I can paste that string and simply flip the condition. So instead of greater than, I'll now make it less than or equal to. So anything with a tolerance band less than 0.2, we'll now apply the second rule, which is going to be roughing plus half a mil and finishing with cut compensation. And it's basically as simple as that. So let's test it. Let's clear these operations out that I've just created. Let's go back to the operation navigator, and this time the feature navigator, and this time we're going to create the feature processes. The same as what Steph showed, we can go down to our operation sets that we've just created, and you can see that under that slot partial rectangle, I've got those two feature groups and associated feature processes. And now in NX, you can see, yes, because the tolerance is greater than 0.2, it's created a single operation to rough and finish that cavity, that slot. So going back a step to the start of the process where I showed you that we have associativity with design, if I just jump back into the design part, say the designer's made a change, they've decided that this a dowel or something that slides into this slot that needs tight to finish, we'll change the tolerance to a bilateral plus or minus 0.05. So they give us a tolerance band of 0.1. So now, if we go back into manufacturing, we can see that PMI has changed. We need to now go and validate that change by approving it, because obviously we need to be made aware there's a change. Yes, I want to accept those changes in the tolerance. And then we can delete that previous operation that we created automatically and recreate the feature process on that feature. And this time what you'll see will happen is it reads that tolerance value, and that value is now driving the operation selection, the tool selection out of the library to determine what sort of operation type we need to use. So now there you can see we've created the two operations. So it's all very well me showing you this on this test part, this teach part, sorry. But let's open up a component that's it's already a CAM setup, and it's got a multitude of slots. Slots of different depths, widths, corner radiuses, and in this case, tolerances that have been applied to it in PMI. Because of the logic and intelligence behind feature-based machining, I've been able to add certain logic into the feature finder, which means that it will work out depth of cuts, tools to be selected, depending on certain parameters from the features. So what you're about to see here is we select all those operations, create feature process, again, looking at the same rules that we just created, and we will almost instantly, very quickly, create a whole set of operations for these slots. Okay, there we go. So as you would expect, 4 of them have got a tolerance of plus or minus 0.25, a tolerance band of half a mil. 2 of them have got a plus or minus 0.05, so 50 microns, so that's a tolerance band of 0.1. So 2 of them fall within the category of requiring what I would expect to be a roughing and a finishing operation, and all the rest are finished in one go. Okay, so there again, you can see an example of the depth of cuts and the difference in the size of the features. But we've still been able to automatically create the operations to cut these features. Okay, so I suppose the final thing to show before I close is, again, let's make a change. So let's just prove that by updating the tolerance on that 25 mil slot, again, jumping into the design part, we'll automatically update the feature processes that are selected that are driven by the PMI. So let's make this plus or minus 0.1. Let's put it right on the threshold of that rule of rate at less than or equal to 0.2 and rerun the feature finding. So again, we have to approve the changes, and then we will delete out the now out of date operation, and we will create a new feature process on that feature. And that's it. Fantastic. We've now created that rough and finish operation. So quite a simplistic example, but a nice example of showing how PMI can do more than just, add a reamer in. We can actually define what sort of operation process is going to be used on the shop floor, whether it's going to be 2 operations, 3 operations, whether it's going to be a helical mill, or whether we can drill and ream. There's a lot of logic and power that we can apply in feature-based machining. And as I said before, we've got the feature-based machining kit, which is available to anybody. Obviously, you need an NX to use it, but that's we can get around that as well with the new cloud trial that we can do for NX CAM. So if there's any questions on what you've seen, please put them in the chat, and we'll pick them up at the end. Thank you very much.
So there, I guess we had a little bit of a deep dive of a couple different subjects on there to try and show you what we can do with feature base. With that, of course, it can get a lot more elaborate to cover that. But maybe next we can talk a little bit about JK Machining. I don't know, it's a mold company here based in the U.S. and as it literally says there, they produce classes of lots of different molds for tier 1 and 2 and tier 2 suppliers, right? They have just 15 employees, so that's a large, operation or a large company. Sometimes everyone says, oh, people in NX, it's only used in these giant companies, et cetera. But actually, NX is out in lots of machine shops with this kind of profile, 15 to 20, 30 employees with that. And so their challenge was just like many others like that. They wanted to cut the delivery times and the cost to manufacture their high quality molds, right? So with that, this is some of the good features I really had solved by using NX with feature base. So it was taking them 18 to 22 weeks to build the tool for automotive. And by using automation tools inside of NX, they're down to 10 to 12 weeks. So they almost cut that in half of the amount of time to do that. And so that's really let them expand their business and lets them get to market much faster with that. And their key to success was they do use NX in design, they use NX in CAM, right? And they like that integrated feature to do that, because if there's any changes and things that happen inside of the tool, those can get communicated, as we've seen, right down into manufacturing, saving that time, along with using feature base, to handle that and have all the proper cutting procedures and our tolerances on tools. With that, they also use NX's high-speed machining capabilities inside of NX in 2.5 and 3 axis, like that. They also were able to leverage and save and reuse their best practices, as you just seen what Joe had shown there, and some with Steph, showing there that they can define how they want different features to be cut with that, along with the standard features in feature base, that for all their standard kind of holes, pockets, and slots like that. They also have use of 5-axis machining, right? And we went back in, obviously people in the mold business like that, there's been a large move into the 5-axis marketplace for quite a long time, going in that to really have higher quality surfacing capabilities, right? And reduce the amount of tool path it would take to be doing with, say, form tools and our tapered tools. So overall, if we really look at that as a summary, when it comes back, is JK have reduced their mold development time by 45%. Their programming time that it took to program all the components inside of the mold and the tool was increased by 70% faster programming time. And as you guys know, if you're in a mold business, that is a substantial amount of time, especially as Lars was talking about, is doing all the plate work to come back in. That can really cut down a tremendous amount of time. So overall, that led to them to over 4x shorter machining time in the tool and capability in order to produce the desired cutting path for their shop practices the way they wanted to do that, and along with optimized tool path. And finally, it's just a statement from the owner or the president, from Henry Calton, said is really that automation, it continues the improvements with NX, help them build the reputation of delivering high quality molds on time. And that's how they stay competitive and they grow their business. And that's really very good testament to in the very beginning when we started like that. It says what drives people to the challenges is it's competition, and to stay that. And in order to remain competitive in the global market space, you need to automate as long, because everyone there also is automating. So it's the best way to really remain competitive and increase your quality of your delivered products.
Okay, I just wanted to let you all know about our NX training. We are one of the only Siemens certified 4.0 training partners in the country. So we offer NX CAM and NX CAD training all year. And I wanted to list the upcoming NX CAM virtual trainings that we have offered. So we have the manufacturing fundamentals, the CAM fixed and multi-access milling, the CAM turning manufacturing, and the CAM post configurator. So you can find those dates and registrations on our website at camlogic.com-training, or call us and get scheduled for any of those classes. Really, our trainers are the best, so you're in good hands. So thank you all for joining us today. Thank you, Brian. You did a wonderful job. If you have any other questions, please feel free to reach out, and your account manager can answer anything moving forward.